This code is about knapsack problem. I can kind of go over first what this is about. Oh, this is the wrong one. This is correct. So create a function that generates all subsets in the knapsack problem. Its input parameters area. So we need a 2D array where each row represents an item, and then a column 0. So the first column represents items weight, and there is a limit for the value. And then the column 1, the second column, represents items value, which is has also a limit between 1 to 5. Then we need number of arrows and the maximum capacity. In addition, the function will show whether a subset is valid or invalid. Also, at the end of the function will show which subset obtains the maximum value. Subset, only one subset. Create a program that randomly generates 4 to 2 array in capacity value 8 to 13. Display the array content and the maximum capacity. Then execute the function described above. So I kind of made some small changes to the problem, how I approached it. So I left a comment here. The problem asks for functions, but to keep things in order, I will create a class. So basically, they're called methods inside of class, not functions. It'll be easier to follow. I mean, for me, it'll be easy to follow. Or whoever is going to use the code, it'll be easier. I doubt will anyone use it, but since it's only for assignment purposes, for school purposes. Okay. So here, I'm creating a matrix, and then it will ask. So I implemented inputs, and it will ask for how many rows do you need. Put a limit to it because the problem asks for it, and then another input option is to put the number of the maximum capacity, and it's limited for between 8 to 13. So then I created this is the matrix variables, the capacity value method variable, so it's only the capacity, so the maximum value, the maximum weight. I'm sorry. This is the highest value, so we set first the max value to 0, and then the first subset is going to be set to the max value. The subset's value is going to be set to the max value, and then that's where I start to compare with the other subsets. And then we're going to put the best subset on inside this array. So this is the function that create the matrix. Here we have the row, number of rows, and then if an error statement that if you input more or less than 4 to 6, it's going to print this one. And then it creates the matrix, adding random numbers through the limit, adding the weight, and then adding the value. So at the first column and the second column. And then we print the array, and then that's where the maximum capacity function comes to place. It's going to ask for 10 to the maximum capacity. Of course, it's going to have for an error statement, and it's going to print the maximum capacity. Here it's going to generate all the possible subsets. All the possible subsets, basically. From, let's say there are 4 items, and then 2 items that's going to add. So 2 subsets, the add of those 2 subsets, the add of those 3 different subsets, and so on. Depends of if there is with 4 or 6 or 5. And then the highest value. This is where the knapsack problem is going to be solved. First, we're going to generate all the subsets. And then we're going to clear the previous subset. And then this is where we set the value to 0 as well. That's where we start. That's where we start comparing all the different subsets. And also display. We're going to display all the subsets, but then meanwhile we're going to compare for the maximum value. So here we go. This is for subset in subsets. So it's going to calculate the total weight and value for the current subset. And then it's going to go to check if that current subset has valid. So does it go over the capacity or not? And if it does not, it's going to be valid. It's going to be valid, and it's going to print its total weight and its total value. And if it's not, this check if the subset has the highest value. So if it has already the highest value for the total value, not the total weight, is going to be set to. So the max value is going to be set to the total value, and that subset is going to be added to the subset, the best subset. And then if not, if the subset does not have a weight that is smaller or equal to the capacity, to the maximum weight, then it's going to print invalid together with the total value and the total weight and the specific subset, the current subset. It's being iterated. If the best subset exists, print the best subset with the highest value. So this is where you print the best subset and sets the max value. And if there is not, which there's two possibilities, if there's an empty array, or which it shouldn't be because it has between 6 rows, but let's say it happens. And the other way that this can be print no valid is if all the subsets have exceeded the capacity, so have exceeded the maximum value. So let's run this code. So let's try it with the highest number of rows, and then let's put the lowest capacity. So if we can have a chance, very low, but let's see if that was going to work. Okay. So this is all the subsets that have been printed, and yeah, I see many total values. Well, as many subsets as being added together, so the number of subsets is increased. The one that's going to be added, the higher chance of exceeding the capacity. So I think this is going to be the maximum value, but let's check. Oh, there's a 5. Oh, the total value. Okay, here. I saw it as a weight. I apologize. And this is valid. Okay. Yep, so this is the best subset. And it's valid. The other ones that have exceeded the capacity is invalid. Here is the best subset. And that's about it.